All right, so for 2.2, we looked at multiplying decimals. And we looked at it without a calculator, so doing some mental math. And we said, well, what happens when I have, let's say, 325.3 times 1.4? So looking at this multiplication, we said the first thing we want to do, right, our first step, is to get rid of that decimal. Okay, because we said the decimal doesn't actually make a difference when we're multiplying, because when we set this up and we line them up, we are going to line them up all the way to the end, all right? We are not lining up the decimal. When we multiply fractions, all right? That's why I said it's easier just to get rid of it. So I just see it as 3,253 times 1,4, because that way it's a little bit easier to understand how to actually multiply. So now when I have this situation, okay, and this is just one method to do it, okay? I'm actually going to call this method 1. All right, because a lot of people said, oh, I actually prefer to keep the decimal. That's totally fine. That'll be the second method I do. But for method 1, we want to get rid of the decimal. So this is actually 3,253 times 14. And if we were to do this multiplication, well, we would set it up this way, okay? We do not want to do this. Where that decimal point is, all right? We don't want to be putting it at the end here. All right, let me show you one more time here. I don't want to do it here. All right, because that means I have to put zeros in for this place, and I'm going to have to do all of that multiplication. And while I'll still get the correct answer, that is way too long, okay? It is not going to be efficient, all right? So we are not going to do that. We are just going to get rid of that decimal. We're going to just multiply these two numbers. Now, as a reminder about, for us, for those of us that don't remember how to do multiplication, we always start with this number here. And we go 4 times 3. Well, that gives me 12. So I put the 2 down here. I carry the 1 over to the next one. And then I go 4 times 5, which is 20. And I add whatever's on top here. So it's 21. So I put the 1 here, carry the 2. Then 4 times 2 is 8. I add this 2 here. That's 10. Put the 0 down, carry the 1. 4 times 3 is 12. Plus 1 is 13. Now, this is so important, and so many of us keep forgetting this during our activities here, is that once I'm done with the 4, a little X goes here, okay? Some people put a 0 here. It doesn't matter. The point is you are done with this column, all right? You're not doing the 4 anymore. You're moving over to the 1, and you're going to do the exact same thing now. So 1 times 3 is 3. 1 times 5 is 5. 1 times 2 is 2, and 1 times 3 is 3. And now with these two numbers, I'm going to add 2 plus nothing is 2, right? This X is just a placeholder. There's nothing there. 1 plus 3 is 4. 0 plus 5 is 5. 3 plus 2 is 5. And 1 plus 3 is 4. So now I have my answer. It's a big number. And now I actually have to put back the decimal. All right? And so what happens is when we put back that decimal, all right, we can use one of two methods, all right? We can use either estimation or the loop method. So this is where I'm saying there's two methods. Now, you could have multiplied using keeping the decimals here and doing the exact same thing. You disregard the decimals. They do not have to line up. These ones just happen to, all right? But they don't have to line up. And then let me just get rid of that so it's easy to see here. And then I still am going to, I'm either going to estimate or I'm going to use the loop method about where the decimals go when I put them back in. So let's estimate first. So when we look at that original question, all right, what is 325.3 really close to? Okay, we're thinking super simple numbers. Well, it's close to 300. Okay, this is our estimate. 325.3 is close to 300. And 1.4 is close to 1. So 300 times 1, well, we know that that's going to be 300. So our answer has to be roughly around 300. So if we go to our answer, the answer that would be closest to 300 would be if my decimal was there, 455.42. Because anywhere else, our answer would be too far off. Okay, we can't put it here. That would be 45,000. That's too far. We can't put it here. That'd still be 4,544. We can't put it here. That's 45. So all these decimals are not in a good spot. This is the only place it could be put. So that's our estimate way. Now the second way we could do it is using the loop method. And so if we go here, let's get rid of our decimal here for a sec. All right, if we go back here, let's count how many loops it takes to get to the decimal here in our answer. So we start here and we go, oh, there's our decimal. That's one loop. Okay, then we go to the second number and go, okay, how many loops does this take? Oh, it takes one loop. So in total, one loop plus one loop gives me 2 loops. So this question had 2 loops. So that means my answer, I need to do 2 loops. So we start here, we go 1 loop, 2 loops. And that's where my decimal goes. Now notice it's in the exact same spot as our estimate, all right? It's just a different way of approaching it or trying to figure it out, okay? So when in doubt, estimate. Make sure your estimate actually makes sense when you go back to your original equation, and that way you actually know if you did it correctly, okay? But the key point is making sure that we push that number all the way to the end. All right, and that we remember our multiplication, our long multiplication process.